Hello, everyone, and welcome to Office Hours with the Meter Environment Team. Today's session will focus on hydraulic conductivity and its measurement methods with our experts Rivera and Shaun Weldon, whom I will introduce in just a moment. But before we start, one housekeeping item. If you're watching this video and you think of a question you'd like to ask our science experts, we encourage you to submit your question on our website at metergroup.com. Someone from our science and support team will get back to you with an answer via email. All right, with that out of the way, let's get started. Today, our panelists are research scientist Leo Rivera and application specialist Shaun Weldon. Leo Rivera operates as a research scientist and director of scientific outreach at Meter Group. He earned his undergraduate and master's degree in soil science at Texas A&M University. And there, his research focused on the impacts of land use and landscape on soil hydraulic properties. He also helped develop an infiltration system for the measuring of hydraulic conductivity used by the NRCS in Texas. Currently, Leo leads Meter's collaborative research efforts and focuses on application development in hydrology instrumentation, including the SATURO Infiltrometer and the HYPROP. He also works in R&D to explore new instrumentation for water and nutrient movement in the soil. Shaun Weldon is the product manager for hydrology instrumentation here at Meter. He earned his bachelor's in environmental science from Western Washington University and his master's degree, also in environmental science, from Washington State University. During the 11 years he's worked with Meter, he has worked in R&D, product development, and now customer support. So thanks for joining us, you guys.
Yeah, thanks, Brad. Glad to be here.
Okay, let's get started taking some questions. Thank you again for all these questions that have been submitted. And our first question today is, what are the most commonly used tools for measuring hydraulic conductivity?
All right. Well, that's a good question to start with. And there's a lot of tools out there. Let me see if I can think of a few. The most traditional methods that I can think of, actually, first, before we dive into it, we should break it down. There's saturated and unsaturated hydraulic conductivity.
Right.
So you're not going to use the same tools to measure saturated versus unsaturated hydraulic conductivity in most cases. Well, actually, in I think nearly all cases.
Yeah.
And the other question, I guess, is field versus lab.
So I think that's a question that we get a lot is when do I want to do field versus when I want to do lab hydraulic conductivity measurements. And generally what we tell people is if you're really interested in knowing what the actual conditions are in the soil there, doing those field measurements are going to be key so that you don't have that disturbance from taking those samples into the lab.
Yeah, exactly. Yeah, and if you want to learn more about that, watch our webinar on this. That's going to be coming up in July. But when it comes to the actual methods, typically some of the most common methods used are your ring infiltrometer methods, your double and single ring infiltrometers. Those are your field methods. And we'll dive a little bit deeper into some of the different techniques for that. And then for unsaturated hydraulic conductivity, it's the most common method is a tension infiltrometer. In the lab, we have tools like TempiCells, got the KSAT, pressure plates. What else? I mean, there's other tools out there, and borehole permeameters. So there's a lot of different ways to make these measurements, and they all have their pros and cons. So it's kind of something you have to do your research and figure out what is the best tool for you.
All right. This next question is asking, can we use the HYPROP for green roof material, knowing that it is coarse-grained, to measure unsaturated hydraulic conductivity? Will the coarse material impact the results?
Yeah. Do you want me to take that one, or do you want to take that one?
Sure, I'll jump in with whatever. Yeah.
Yeah. So for coarse material with the HYPROP, the biggest challenge is that you don't get enough difference in the tensiometer measurements to calculate unsaturated hydraulic conductivity. It's a great tool for doing the retention curves, but when it comes to measuring unsaturated hydraulic conductivity, you do need to have a difference between the upper and lower tensiometers, right?
Yeah, definitely.
Yeah, so there's definitely a challenge. It depends on how coarse the substrate is. I think the other thing that you have to take into account is that a lot of these materials also have the structural pores around the material, but then in a lot of these, there are different aggregates like crushed brick or other. We've seen a lot of different materials. Some of them are lighter materials. They have inner structure as well. So So you'll see what we typically refer to as a bimodal retention curve. And that indicates that you're going to have some weirdness happening with the hydraulic conductivity as you transition from the large pores to the small pores.
Yeah.
So,
and I think knowing that the composition of that material is going to be key, because we have had some people that have used these on almost hydrophobic materials for green roofs, and that kind of exacerbates that problem that you're talking about with the differences between those heads, because it empties out so quickly.
So hydrophobicity is a whole nother another beast that we will not cover today.
But I do want to say that if anybody has questions about the materials, give us a call. We'd be happy to talk through the application with you as well, and kind of give you pointers for that kind of stuff, because we do have a lot of case studies and a lot of experience with these instruments as well.
Yep.
All right, this next question is asking, how does using the SATURO compare to a double ring infiltrometer, and how does it measure sorptivity?
Okay. Well, that's a really good question. They're both ring infiltrometers, right? Yeah. So the double ring infiltrometer, the thought process there is that the outer ring is going to buffer the inner ring from three-dimensional flow. And the goal in any of these hydraulic conductivity measurements is we're trying to get this one-dimensional hydraulic conductivity value. And when you have three-dimensional flow happening, it makes things challenging to actually get that one-dimensional value. So typically we have to make corrections for that lateral flow, that pool, the sorptivity that the soil has on the water. And so the concept that the double ring infiltrometer buffers that inner ring there's that concept that the double ring infiltrometer buffers that inner ring, but as we know, and if you look at the literature, it doesn't. And so you still have to apply correction factors. And typically what we have to do, we have to look at the soil type, right?
Yeah.
And so we have to guess or guesstimate. No, we have to make an educated guess at what our soil type is to do these corrections with the double ring infiltrometer, or a traditional single ring infiltrometer. You would have to do the same thing. Whereas the SATURO uses the multiple punted head analysis approach. So it's a single ring. Often you can refer to it as a pressure infiltrometer, but we use the multiple pressure head analysis approach, which gets to that next question. Part of the question is, how do we measure sorptivity? So we look at the difference in the infiltration rates at the two ponded heads, at those two different pressure heads. And if you look in the theory section of the HYPROP manual, you can look at that. We've also kind of dived deeper into this in past webinars by Galen, where we really dive deep into the theory of how it works. But it uses that approach to directly estimate the sorptivity. And so that eliminates our need to make an educated guess about our soil type. And we have a tool that can automatically then use that value to do the corrections from that ring to get that one-dimensional flux value. I don't know. Am I missing any other things there, Shaun?
I think also just the practice of it means that it's a lot easier to use and to install. It's a lot faster. Anybody that's done a double ring infiltrometer knows you need a ton of water.
Yep.
You need a lot of time. And you're going to have a lot of disturbance as you put that into the ground.
Yeah.
And one of the great things about the SATURO is that it's the single ring that needs to be pounded in there. It's much smaller, and you can do it typically with less than 5 gallons of water.
Yeah.
And you set that time period. You don't have to be babysitting it to check that the whole time. You just kind of set it, and you can walk away and set another one up to be going. And that's one of the things that I really appreciate doing this, is because I've done the double ring ones. It's a lot of work, and it takes a lot of time. So not only is it more accurate in the methods, but it's also a whole lot easier to set up and to use.
Yeah, that's right. And I'm going to share a really short, I'll try to make it short, story here. So we were just down visiting some of, so those that know me, I went to Texas A&M based on the intro, and we were just back there visiting some of our colleagues, and we were doing a workshop down there as well. And my former advisor, or one of my former advisors, was there, and we were talking about measuring hydraulic conductivity. And I used double rings in my study, and I spent a lot of time in the field. Typically 10-hour days out in the field making these measurements. And Dr. McInnes chimed in while we were doing the workshop, and he's like, and made the comment. He's like, how long these measurements take? they take so long that when Leo was presenting his, or was working on his thesis and on his master's defense that I brought in, I was looking for an aerial image of my site that I was taking these measurements at. So I went to, I think it was Google Maps at the time, and I looked at the image and I was like, wait a minute, that looks weird. What's in the field? And I go into, and I zoom in on that, and that was me in the field making those measurements day after day. And so I just think it's so funny that he remembered that.
Yeah.
I mean, this is 15 years ago now, and that he still brought that up at this workshop. So double ring measurements take a long time. Yeah. I mean, so do the SATURO does too. It still takes time to make the measurement, but it's automated, so you can go off and do other stuff while it's making the measurement.
Right. We were visiting a group down in Oklahoma last year where we were trying to measure several 100 acres, I think, where we had sites set up. And the nice thing was we could set one up, we could go drive to the next spot, set another one up, drive to the next spot. And by the time we came around, that first one was done, so we could just pack it up and put it away. But they'd all run just perfectly. They had enough water. We didn't have to sit there and babysit it, which was great.
That's awesome.
Yeah.
Yeah, that would be the dream. I wish I would have had that when I was doing my master's thesis.
Yeah.
All right. This next question is asking, can the SATURO, so this is another SATURO question, can the SATURO be installed at the bottom of basins? And then also, what is the power source and how is the data collected?
That's a really good question. And I think that's actually coming from one of our previous webinars where we had two visiting scientists from Villanova talking about their work on rain gardens and using the SATURO to measure the hydraulic properties of these rain gardens of both the native soil and the installed, the engineered soil. And so they're referring to the drainage basins that you would use to capture runoff from various impervious surfaces. Absolutely, there aren't a lot of limitations on where you can install the SATURO. Obviously, though, if that basin is flooded, I don't think you can really make measurements in the basin if it's flooded with water. But if it's in unsaturated conditions, you can absolutely install it in almost any site that has soil or some, most soil materials. Unless there's really big rocks, those are challenging. Yeah,
and you want to make sure that you're following the installation instructions, so it's not on a slope that's super high or something like that. But absolutely, we've had a lot of customers that have installed them in these kind of situations, and they work great. One of the nice things about it is because it doesn't take as long to set up and run, is you can leave it there for your run, remove it so that if there is a danger of flooding, then you can have it out of there before that happens.
Yeah, exactly. And what's awesome about the SATURO is everything is internally contained into the brains of the device, the control unit. It has a 12-volt battery on board that, when charged, typically can last multiple days of measurements, although we always recommend recharging the device when you come back at the end of the day. Everything's recorded on board. It has all of the smarts, and it even does the calculations on board, which is really cool. When you're done, it outputs the hydraulic conductivity value, which anybody who's done the traditional methods know they have to come back, typically import things into Excel or some type of macro or whatever, where they're doing the calculations, and there's a lot of post-processing involved to get the final KS value, and you don't have to worry about that with the SATURO. So it's all stored on board, and you can download the data when you get back and pull it off, and you have all your final values.
Yeah, and one of my favorite things is you can actually look at the screen as it's happening. You can look at these graphs in real time, looking at the flux, at the pressures. You can see where it's at in that process.
Yep.
You don't have to sit and kind of try and remember, how long has this been running?
Yeah.
It's super handy to be able to look at that in real time.
No, agreed.
This next question, which method would you suggest is best when designing a drip irrigation system and selecting an appropriate dripper flow rate?
Yeah, that's a really good question. And I don't know, I guess I would say ultimately the first thing you want to do is figure out your saturated hydraulic conductivity. Because that's going to be your biggest limiting factor. You don't want to pick a rate that's going to exceed your saturated hydraulic conductivity. But I don't know, I kind of also think it's important to understand, and most people aren't going to do this because it's way too much work probably, but when you were dripping at subsurface, water's also moving up. And so I think understanding the unsaturated hydraulic conductivity is important as well.
Yeah, absolutely.
And because you want to know how it's able to infiltrate up from there. So I would still say that something like the SATURO for your surface measurements would be good, but maybe, I don't know, pulling core samples and running them in the lab to get your unsaturated hydraulic conductivity properties would be a good approach.
Yeah, I was going to say the same thing. I think that's really important. And I think depending on where you're doing this, you're going to be making sure that you take samples that are representative of different areas in your field that you're trying to measure. So, here in the Palouse, we have very uniform soils, but we're kind of an outlier in that. So making sure that you're getting samples and tests that are representative of that area is going to be really important as well.
Yeah, agreed.
Okay. Next question. Using the HYPROP, what is the range of initial pressure values of the top and bottom tensiometers that's acceptable?
Awesome. Maybe, Shaun, I'll let you take this one first, since you're now our resident HYPROP expert.
Yeah, so that's a great question. We were talking a little bit beforehand about the pressures that you might see on your tensiometers as you're setting up. I think that's going to be the key to knowing this is how well you're setting up your HYPROP. We do have a lot of videos on our website now about how that initial degassing phase, which is probably one of the most important phases of your HYPROP setup. But also making sure that when you're putting those tensiometer shafts in there, you're paying attention to that pressure in the setup wizard, or the refilling wizard.
Yeah,
that's what we call it now. So initially, those differences between the two are probably going to be pretty small because they're both going to be in very saturated conditions. But it's depending on your soil type, it's not uncommon to see the difference, especially in that top tensiometer, to change pretty rapidly as that drying front comes down.
Yeah.
So those soils that tend to lose the moisture more quickly are definitely going to see a difference in that top tensiometer pretty quickly as well.
Yeah, and I think some of the initial differences that come from your setup really depend on. I've seen it depends on if you pull your sample out from the water and set it up, how long it sits there. Mm-hmm. And I think the other piece is probably making sure when you set it up, I always like to cap it and let it sit and equilibrate after, because when you flip the sample, there's always a slight redistribution of water.
Yeah.
And so it's always good to do that and make sure that it's had enough time to equilibrate. And you'll know in your data if you didn't, because you'll see kind of a transition phase where it's re-equilibrating before it starts on its drying phase. But outside of that, I don't know. I mean, some soil types you see bigger differences.
Yeah.
So,
and if you do see that redistribution, that's okay. We can eliminate those data points from the HYPROP. It didn't ruin your run. Let it finish. Yeah. And then you can select which ones you want to remove for that part as well.
Yeah, that's a great part. Is there's a lot of. I mean, it's just making slight corrections in the data, because we all make mistakes when we set stuff up, and so it's fairly easy to correct most of those things.
Yeah.
So following along with that, this next individual is asking, while they're using HYPROP fit, how can they compare different replicates of samples?
So yeah, that's a great question. We do get that question a lot from people that are running samples on the HYPROP. And one plug I do want to put in here is, if you haven't updated your software from HYPROP Fit to laborious soil view analysis, I'd recommend you do that. The HYPROP Fit is no longer going to be updated anymore, but any new updates and features are going to go into the laborious soil view analysis software. So there's my little plug for that.
Good plug.
The software makes it really easy to combine files and to put them together to do this kind of analysis that they're talking about. You can easily join these files together of different runs of different sample locations. If you're looking at a large spatial area and you kind of want to just get a feel for the average of that, you can definitely add those together. In the laborious soil view analysis manual, which is now on our website, there's detailed sections about how to go through and do all of this and do this analysis as well.
Nice. Yeah. I mean, it's, I'm really glad to see this question, because it's really important to replicate your measurements. I see this a lot where people, I know some of these measurements take time. And so it's really important to actually go out and take the time to make replicates, because sometimes we grab some anomalous sample, and then if we use that anomalous sample to represent the entirety of that soil that we're trying to represent, that can be really problematic. And it's just good practice.
Yeah.
It's good practice to replicate your measurements, and that's why that's built into the HYPROP software to be able to do that.
Yeah, absolutely.
All right. Next question. Are any of these methods appropriate to get saturated and unsaturated conductivity in a clay soil?
Yeah. Well, I will start with this one because that's where I've spent most of my career is in clay soils, doing a lot of measurements in the Blackland Prairie in Texas. And absolutely. Most methods we've discussed are appropriate for clay soils. There are some challenges depending on how well structured that clay soil or if it's highly compacted. Well-structured clay soils are going to infiltrate water very similarly to most other soil types. It depends on how strong the structure is, how the macropores are within the soil, but they're very suitable for that. Now, when we go to other clay soils that are like compacted, maybe say for landfill liners or landfill caps or clay liners and drainage basins or something like that, where you're trying to keep water from infiltrating, those are a little more challenging. Mm-hmm. I think to some extent, the SATURO can be used for most of those situations. You do need to increase your pressure heads to try and get a little bit more water moving through. But there are some techniques where if we take a core sample, the KSAT, we have a method for really low permeability clay soils in the KSAT. So that's an approach.
Yeah. Yeah. And one of I think the key that you said there's really understanding that soil that you're working with. For the SATURO, we have these tables to talk about the recommended settings, and we get a lot of questions about people, where people ask, well, what about my specific soil? And it's going to take a little bit of guesswork and a little bit of trial and error sometimes to find those perfect settings for your soil. But it's pretty easy to find eventually, and you can get great results with clays. Absolutely.
Yeah. Understand your soils and what you're trying to measure. And I didn't really touch much on unsaturated hydraulic conductivity, but it's the same. I mean, tension infiltrometers work well in those soils as well, but you might have to be a little more patient because sometimes those measurements take longer. So that's just part of it. There's patience in these measurements.
So how does plant material in the sample core affect hydraulic conductivity?
Yeah, that's a great question. I'm going to say obviously it does have an impact, but I think the biggest question to ask is that plant material supposed to be there?
Yeah.
Or was it accidentally added? If it's like, say, root biomass, we want those in the soil core to take the measure because we need to understand how the soil is performing in the field with everything that's in it. So root biomass, other, decaying plant matter, things like that. So it does typically, it depends. As roots break down, they leave big channels, and so they leave more macropores that increase the hydraulic conductivity. But we've also seen that a high density of root biomass can actually slow the hydraulic conductivity of the soil. And so there's stages, and that's why we often talk about seasonal variability in hydraulic conductivity, because we know plants go through seasonal variation as well, and the way they're affecting the soil is also a part of that. And as we're doing things like implementing different, say, soil health practices where we're trying to improve the soil health, we're going to see changes in the hydraulic properties. We've referred to those as dynamic soil properties, and this is one of them. It's going to change as various aspects of the soil are changing. So it does affect it.
Yeah, and I think that's important. That's why it's important to make sure that you're not just doing a one-time test and assuming this is what it is. Especially if you're doing something looking at improving soil health, you want to be taking these measurements yearly or sometimes twice a year, depending on the conditions that you're looking at that are changing, because that will, like you said, it's dynamic. It's going to change, and that's what we want to look at is how that's changing.
Well said.
All right. So along with that, how many measurements are needed for characterizing conductivities for a sloping area, and at which positions of the slope should it be measured?
6.
6 is the magic number. No, actually, that's kind of right. That's actually the study that was done by the folks from Villanova. they found that in most cases 6 measurements was the right. So well done. But it does depend, and I think that's like the story of half of these questions. Is It depends. And it depends on how variable that soil is on that sloping site. We want to try to cover the variability and at least replicate by 3 across those zones of variability, if not more. And when it comes to like what hill slope position you want or what slope position you want to measure, I mean, I personally want to measure on all of them, and that's what I did when I was looking at landscape position effects on soil hydraulic properties. We need to understand what all the different landscape positions how they behave. So all of them.
Yeah, and that's what I tend to tell people is as many as you can like feasibly do.
Yeah.
When I was at Western Washington University, we did a lot of studies we were trying to look at how plants stabilize slopes and things like that. And so we're looking at these kind of things. But I think what you said about understanding your soils in that area is very important as well, because, in Western Washington, it's all glacial till. So if you move 3 feet, you've got a different soil type that's going to behave very differently. So taking multiple samples and testing at those sites is super important, because you've got not only different plants and different structures, but you've got different soil types there as well.
Yeah, no, that's exactly right. So it always ultimately comes down to understand the variability in your site. Try to characterize your site to the best of your ability. There are a lot of tools out there. You can use soil survey.
Yeah.
We used a device called the M38 to characterize the zones using bulk EC measurements. So there's a lot of ways to look at it. You just need to do a little background research on your site before you go out and make your measurements.
Yeah.
I just had a follow-on question, because I know we've heard this before, is when installing on slopes, maybe I could back this up. Would there be anything that you would add when it comes to installation, either SATURO, MiniDisc Infiltrometers, or others, when you're installing them in slopes? Is there a particular, are you installing it perpendicular to the slope? Are you installing it, parallel to a flat surface? How exactly does that work?
Yeah. Personally, the way I like to do it, I don't want to disturb my site surface at all. I want it to be intact what it is. So there's a limit on how steep a slope you can measure on, but you can measure on slopes. It'd be nice to come up with an exact number, but ideally what we're doing is, say for the SATURO, there's a level sensor in there.
Right.
We want that level sensor positioned centrally on that slope. That way we're getting an average water level across the slope. The MiniDisc is probably a little more challenging, because you actually need it. Need it level.
Yeah, because if you're trying to hold that one, then you're going to be applying pressure, and that's going to change the readings that are there. So, for things like that, you do need to make a little flat spot. But luckily, it's a very small footprint. For the MiniDisc.
Yeah, and oftentimes you can build up a little sand bed with the MiniDisc that you can make flat. So that's an easy way to handle that. But I wish I knew an exact number of like what percent slope we can't measure on. It's probably somewhere around 15%.
Yeah, I think that it does say in the manual. I think it gives us an exact degree, but I don't remember what that is off the top of my head.
We were probably smart enough at one point in time to look at it, but it's been a while.
Read the manual, right?
That's right.
All right. Thanks for humoring me on that one.
No, great follow-up question.
All right. This next question says, do I need to wait for all the water in the MiniDisc Infiltrometer to go through the soil, or can I do my calculations after a certain period of time?
That's a great question. So the answer is no, you don't have to wait for all the water to go through. There are going to be some soils that are just going to that have very low infiltration rates that are going to take a long time for that water to go through. I think in the manual we typically recommend that you get at least 6 or 7 points in that curve, just to get a good representative rate in there for that calculation. But yeah, it's not something that we have to wait for all of it to go through. And you can adjust, your table there as well for the time that you're taking those measurements and things like that. If you are having a very low infiltration soil.
Yeah. The MiniDisc uses I believe it's called a transient method. So it doesn't need a lot of measurement points, because what it's going to do is interpolate based on your measurements to a quasi-steady state. So that's a really neat thing about such a simple device.
All right, this next question, how do surfactants affect the hydraulic conductivity?
Yeah, it's a good question. So surfactants affect the way the water is attracted to a surface. And so anytime we're applying surfactants or anything that's going to change that wetting angle, it's going to impact the measurements. If I had to think about this a little bit more, I would say surfactants will likely decrease the hydraulic conductivity, or am I thinking about that wrong?
I think it increases.
It would increase, yeah, because is it gonna decrease that wetting angle?
Yeah.
Yeah, so that makes sense. Yeah, so sorry, I have to think through this a little bit. So it changes the how the water is bound to the material and how it's going to go. It's going to make it go through faster. And if we add things that are going to make the soil more hydrophobic, then you're going to see the opposite effect, where it's going to decrease the hydraulic conductivity, or in some cases, actually not infiltrate any water. We've seen some cases where soils that you would think, like you pond a bunch of water on there, like, oh yeah, it should start infiltrating, and it doesn't, because the soil is hydrophobic. And again, I said we weren't going to dive super deep into hydrophobicity, but it's a challenge.
Yeah.
And that just happens naturally in soils, especially after fires, for example.
Yeah.
Those really make soils hydrophobic. So anyways, things like this impact the soil hydraulic properties.
Yeah, and you'll also see, we've seen some kind of natural surfactants as well. If you're looking at like riparian soils, you'll get algal growth and stuff in some of those places that are normally flooded, and you'll see kind of that same effect just with natural things that are there in the soil too. So,
yay, surfactants.
Let's see, we've got time for a couple more questions here. This one is asking, how do you deal with macropores in soils?
Yeah, well, I mean, we all know they exist. Well, not in all soils, but in soils that typically have good structure, good good soil life, worms, activity, root channels, things like that. Macropores are always going to exist, and it's not something we want to ignore.
Yeah.
Right? They're a part of the soil structure, and we want to make those measurements. Now, there are some soils that have such large macropores, like some of the shrink swell soils that form really large cracks, that you could run through a 500-gallon water tank in less than an hour, which I have done. And so those are challenging and really hard to measure in. And there are models out there to try and actually estimate how those large macropores impact the permeability of soils. So anyways, you don't want to ignore them. They're a part of it, but they can be challenging.
Yeah, I think that's important to remember, that you're actually measuring what's going on in the soil.
Yeah.
It's not going to always be a textbook picture, perfect curve, that there's going to be those things. And that's good, because that's what's really happening.
Yep, exactly.
All right, we are close to the end of our time here, so this is going to be our last question. And this final question is asking, how does water chemistry affect saturated and unsaturated conductivities?
Yeah, well, that's a really good question. And I always, this is probably one of the first things I talk about when I'm talking about measuring hydraulic conductivity and trying to teach somebody how to make these measurements, is water chemistry absolutely plays a huge role in how the water infiltrates in the soil. Sodium, which there are a lot of sites that have water sources that are high in sodium. Sodium is a dispersant, so it makes the soil particles separate. Therefore, it's going to kind of destroy some of that structure. And if you're using water that's high in sodium on a site that wouldn't normally have that, it's going to affect the chemistry and how the water infiltrates the soil. And calcium has the exact opposite effect. Calcium is a flocculant, so it helps the soil particles bind together. And so those are actually going to increase the structure over time. So my recommendation is always choose water that's representative of what you're trying to study, whether it's irrigation water, so choose irrigation water from the source of irrigation that you're trying to study, or if it's rainwater, there are ways to make artificial rainwater. So always think about what it is you're trying to actually understand.
Yeah, I think that's great, because we often get people asking us, should we use deionized water to limit that? And obviously we want to try and treat it as naturally as it's going to be in
Yeah.
that condition. So yeah, that's great advice.
Yeah, exactly.
All right. Well, that's going to wrap it up for us. Thank you again for joining us today. We hope you enjoyed this discussion, and thank you again for everybody who has sent in such great questions. Also, if you have any questions that we didn't get to, please contact us via our website at metergroup.com. Finally, you can subscribe to the Meter Group YouTube channel and accept notifications to see previous episodes of Office Hours and to get notified when future videos are available. So thanks again, stay safe, and have a great day.